Okay, we're back. It's COMP100 and it's week 10, lesson 10, part 1. And I'm just going to do a review of methods for a bit in this first part. So I'm just going to go to full screen, and again, it causes some weird effects. So bear with me while I do that. All right, so we talked about a method being almost like a container. And I think that's the right way to call it, a container of a bunch of statements, a set of statements that run kind of thing all at once. So as soon as you call a method, think about a method as a new node, if you will, right? So almost like you call the method, and wherever you call it from, it goes. We divert our flow, our program flow, from the place where we started into the method. It finishes what it has to do, and then comes back out of the method into where we left, where we kind of called it from. That's the first thing. And here's an example of our standard method, which is main. We talked about that last week. So a lot of reasons that we want to use methods is we want to reuse the code, and it's sometimes what we want to do is compartmentalize the code and put it into a method that makes sense, so we can call it again and again. That's another reason why we want to use it. So again, different parts of the method. I think the main thing that you have to think about with methods is this header for the method, which is, again, the access modifier. And what's the default access modifier? Do you remember what it was? Default. So if I don't specify a modifier, what's the default for in C#? Do you remember? It would be on your test for sure if we did this one. No, public as default. Right? If we don't specify what it is, it's public in C#. In Java, it's private if you don't specify otherwise. And in other languages, JavaScript, when you use TypeScript or something like that, or if you're looking at other languages like Python and Ruby, and other languages like that, C++, all those things, most often they're public, not private. That's the most common thing. The next piece is if there's a static modifier, right? That's one of the things you can have there. And then there's a return type we talked about before. Void means I don't return anything. So, I mean, it goes into the method, nothing comes out of the method, right? And then the method name itself. Okay. And these are the different, again, from an accessibility perspective, these are all the ones that we talked about last time: public, protected. The most common, public, protected, and private are the most common access modifiers, if you will, right? And what they do is they tell you when the method is available. How can you, from a scope perspective, can you see the method in different places, right? When you call a static method, then you can call the method without instantiating a new object, which means, let's say I have a new object called date, and if I had some kind of static method of the date object, like let's say, I don't know, there's a method called time and it was static. Instead of creating a new object, like a new date object, I can just say call the time, and I don't have to instantiate anything. And you'll see that as we go forward. Static methods for now, we use them mostly in the main. Our main method is a static method, right? So we don't have to instantiate or create a new object from main. We just have to call main and it runs. Every method has a return type, and the minimum you have to put in there is void. You can't leave it blank. You have to put a return type in there. Okay. Here's an example of our method main, and again, what we have here is one statement that's inside the method. It's inside of our class, hello class. Remember, these are just containers, so this is the outside class. Here, the method main is on the inside, and another object that's inside of our class. And inside of our main method, there is another directive, which is console.writeLine, right? So this is typically what our methods would look like. Here's another method that's outside of our main, right? So we looked at this main, and then outside we declared a new private static void show welcome message method. And what we're doing is we're calling the show welcome message method before this console.writeLine. So wherever we call it, remember the way we call our method is there's no keyword to use. We just use these the constructor notation here, when we say, I want to call with these round brackets or these parentheses, once I use this method and a semicolon, I'm actually calling the method right here, just by calling its name, putting its name in there. Sometimes this isn't enough. Remember we talked about parameters. If the method is waiting for parameters, you got to include them in the method call. All right, so we're going to move forward. So we want to declare variables and constants in the method. And again, when we declare, if this is our method with its own a, remember we tried doing this last time, and we have an integer. This integer has a local scope between these two braces, right? It doesn't impact this scope up here. And we did that example last week where we kind of went in and out of this method, right? When we look at parameters, parameters are almost like things or variables that we want to send into the method. But first, you need to create a. Here's an example of a method that we've declared. It has one parameter called sale amount that it's listening for. It's waiting for this sale amount parameter. It means when you call this method display sales tax, you must include some kind of double value that you put into these brackets to send to this. If it doesn't have a double value, it's going to error out. It's going to give you an error. It's going to say, I'm expecting you to send me something to put in the sale amount, variable. If you don't send anything to me, I'm going to complain. Right. So this is when we pass a parameter to a method, it means only if I've written my method this way. So let's say this is our method, our custom method. We've made it so that it returns nothing. It's a static method, which means I don't have to instantiate it. I don't have to instantiate the class that it's part of. In this particular case, it's part of the main program class, right? And then the name of the method is display sales tax, and then we're listening for a sale amount of double, right? And that reason why we need that is because this sale amount is going to be used to calculate the tax. So if this is nothing, if you don't put anything in here, it's not going to have you can't multiply nothing by the rate to calculate the tax, and so therefore it'll give you a syntax error. It'll crap out. Here's another one where there's the full example. We have the main method, and we're calling display sales tax, and there's two ways to send parameters. One is by passing in the value of my purchase, which is also a double, or the other one is actually physically putting in the actual value. So 35.67 is also valid to send into the sales tax because it's a double. 35.67 is of type double, and so is my purchase. My purchase is of type double, and it holds a value of 12.99. So either way, whether you do it this way or this way, is valid because it's listing for a double. Okay, so that's the kind of stuff. We don't want to. When we require multiple arguments, multiple parameters, they have to be exactly in the order that I declare them. So if this is my new method that I call display sales tax, and now it's listening for sale amount and tax rate, I need both those two things. Then I need double values for both these things have to have a value for this method call to work. Right now, if you notice now, the sale amount multiplies by the tax rate, which are both variables that come into the method. And these anything that I mentioned here inside the method header, right? These variables become local variables between these two braces. So they don't exist, these two variables don't exist outside of these braces. Writing a method that returns a value, well, we need to use the return statement, if you remember. So here's, instead of having void here, we have a new a modification to a method where we actually put the type that we're returning. In this particular case, we're returning a double. So here's we're actually listing in this particular method signature, and the signature for the method means how I've written the header. It's private access modifier, static, which means I don't have to instantiate the main method with it or create an object. Double, which is this is what I'm returning. I'm returning gross. Gross is a double, right? The name of the method, calcpay, and the two parameters that I'm sending in, both of type double, hours and rate. Those are the two variables. So I have to calculate gross, I declare it as a local variable, and I take hours times rate and take this and assign it to its value to gross, and then I return it back to the calling method. And again, it says a return value can be stored in a variable and also used directly, which means I can put a literal, send back a literal back to the calling method. The problem with that is that typically, if we're returning a literal, like a 1 or a 2, like if I return, then why do I have that method in the first place? Why do I care for that? Unless it's a signal that I'm sending back to the calling method. So let's say I have a main method, and in my main method, I'm calling this other method, my custom method I'm using. But I make a check. I'm doing kind of it creates a flag, like not a Boolean, but I'm returning back something like true or false, right? True or false is literal value, right? I'm not actually returning the variable value, right? So I could do that. I could also return a 0 or 1, which is equivalent to what true or false would be, right? Or it would be actually 0 would be false, 1 would be true. Here's an example of the main method, and again, we're just catching up to what we did last week. Our main method, and here's gross pay. I know that I'm going to calculate gross pay by sending my hours and my rate into the calc pay method, right? So I send these two variables, my rate and my hours, which right now are 37.5 and 12.75. I send those two values into calc pay. When I hit this line, when the compiler goes down, it starts reading all these lines, right? When it goes to here, it doesn't go here. It goes from here, it jumps over here, passes the two values in here if they exist, and then calculates the gross, which is the hours times the rate, and returns the gross back into gross pay, which is the receiving variable. Right, here's the receiving variable right here. And then from there, I can print them out. So again, we can send parameters in, depending on the header signature of the method, right? And it has to be in the exact same order that we send them in. And we also are listening for, if we have a return type, in this particular case double, then we have to, the return statement here on the bottom has to match the return type. And the return value goes back, it can get assigned to another variable, just like in this particular case where I'm assigning the value now of calc pay into gross pay. Okay. Okay, here's where, when it comes to methods, right? And this is where I think we got to this far. You see, so I'm gonna just jump out of this for a second and see where we are. Yeah, we pretty much got to this place last week. So I want to try and practice this one. Okay, I'll go back in here and just reset the slideshow. So this is where we stopped. So I want to give you another example here. This is a good example of, I have an array, some nums. And we tried this last week on our own. We did an array and we passed it into a method. Now, array is what kind of type? Is it a value type or a reference type? It's a reference type, which means an array is, and this is a great example of an array, what it is it's a series of memory locations that are tied together with a single name, right? So with a series of memory locations, if I pass the name of the array, I'm passing almost like I'm passing it by reference, which means I can actually look at the memory locations. Whenever I pass an array into as a parameter, an example would be this. Here is one value, right? I'm listening for an integer that's called one value, right? In this new method called method gets one int, right? Okay, let's take a look. When do I call method gets one int in this example? Well, it's right here, right? Well, guess what? I'm passing some nums. Some nums is actually an array. Take a look. Some nums is an array. And it has 4 values, 10, 12, 22, and 35. So if I'm passing some nums x, x starts at 0. So I pass the first value, 10. 10 is a valid value because I'm passing this by value. I'm passing the value of what's in some nums with this index, starting off at subscript 0, right? Subscript 0, 1, 2, and 3. So first it starts in a 10, and when it's 10, it goes into one value, and then I say in method gets one int, 10 is the value, right? And then I set one value is equal to 999, console.writeLine after change, it's still 999, right? Because I'm passing this in by value. I'm not passing the elements in by reference. If I pass the whole array in, I'm passing that by reference, not by value. So if I just do this, if I actually create an index like this isn't passing by reference. This is passing by value because I've actually indexed it. Let's take a look. So it says after the change, 9999. It goes into this method or whatever. And here's the main method, and here's the end of main. They're the same values. Okay, that's cool. Well, here is when I pass the whole array into the as a parameter. Okay, that's a different situation here. So now I'm not passing, here's some nums, here's my array, and here's the name of my array, but I'm not passing one index value. I'm passing the whole array in, just the name of the array. And now listen, take a look at this. My method gets array is listening for a type of integer array we call locally here in this method vals. In the calling method, it's called sum nums. But it doesn't really matter. Sum nums and vals, because arrays are reference types, I'm going to actually get the entire array. I'm not getting it just by reference or by value. I'm getting it by reference. So then, any change that I make to the array in my method, it also gets changed out here in the calling method. So in other words, I go through here and it says, this is what it's going to say now. Here's my integers, 10, 12, 22, 35. It says beginning of main method, right? And I start going through, I'm cycling through. So I'm going to go from 10, right, to 22. It was going to go 10, 12, 22, 35. That's what it's going to do up here. Then it's going to go into method gets array, which is in here. And then it's going to do this. Hold on. And then it's going to do this. It's going to jump in here and it's going to go console.writeLine in method get array. And then I'm going to start writing stuff out. It's going to say 10, 12, 22, 35, just like it did before. Oh, I love how it jumps around like that. That's fantastic. Let's just fix that. I don't know why. Why does it do it to me? Why? Let's go back out. It's the Apple factor. Okay. So that's what it does. So here, when I'm sending it in, this is by value, but when I go jump forward a little bit, when I send it in by reference, now my output's the same. Here's the 10, 12, 22, 35. Here's what happens when I put it in here. After the change, I change everything to 888, and when it comes back into the main method, it's also 888. It's a permanent change when I pass the whole array in, because I'm passing it by reference. It's a reference type. The other reference type that we can pass in is a class. If I pass in a class to the array, which is unusual, or pass a class to the method, that's unusual. But if I do, it's a reference type, not a value type. Okay. So again, here's an example. You can pass a multi-dimensional array. We didn't cover multi-dimensional arrays too much, and I don't expect you guys to remember multi-dimensional arrays. In fact, when I test you guys, you're not going to be tested on multi-dimensional arrays because you most likely will not need to know too much about them. You need to know that they exist, like I said last time, but really I'm not going to go into a lot of detail around them. Okay, so if I pass an array that's a multi-dimensional array, here's an example of I'm passing the whole array in, right? I'm passing, if you notice, there's a blank int with a square bracket, a space, a comma, a space, and another square bracket, and I'm passing the whole scores array in, right? If I do that, this whole array is being passed in by reference, the whole array, right? Not just an item of the array. Okay, let's try this out. Let's go back to our Visual Studio here, and of course it's grown out of control, my Visual Studio, because of my my PowerPoint presentation. Which means, let me just jump out of this PowerPoint presentation for 1 second here, because once I do that, it messes me completely up. From see, my resolution just jumped down again. So I'm going to create a new project now, and I'm going to go into a console application. We're going to call this COMP100, and it's going to be lesson 10, part 1. Okay, lesson 10, part 1. I'm going to press OK. This is where we're going to try some code again. Now remember, I have a wait for key function that I kind of made. So I'm going to go like really lickety split, but don't worry. Here's my Solution Explorer. And in my Solution Explorer, I have my program .cs file. In my Team Explorer, I'm going to make some changes. I'm going to add these in. I'm going to say created BS C# program, right? That's my default. I need to create a GitHub. I need to create a GitHub link. Let me just do that right now, a little repo. Here's my link on GitHub. I'm going to go plus, new repository, and I'm going to go on GitHub here. I'm going to say COMP100, right? And it's going to be lesson 10, part 1. There it is. Okay, so I'm going to take this URI, go back here and go home and unsync commits, and then drop it in here and press publish. And there we go. Okay, so I've got my main program here. I'm going to add in here this wait for key thing that we always do. So again, what it's going to look like is, just really quickly, it's going to be these write lines. So I'm going to kind of do this wait for key, because I'm always going to wait for key here. I'm going to say wait for key, right? And what I did was I created up my own little snippet that I used. But you can, if you want to type these in, you can do that. I'm only going to add in a read key and a clear when I'm done. So when I run this thing now, it waits for my key. Let me just reformat my properties just to get ready for our little demonstration here. It's 20, and I'm going to go into colors, and it's going to be white with a screen text of black, and press OK. There we go. So there's my display. Okay, cool. So I've done all that, and I want to try some methods out. So again, let's try some stuff out where I declare inside my main. Here's my main. I want to declare a variable, and the variable that's going to be inside my main is going to be an array type. So let's go and make an integer array. So I'm going to do one of these, integer array, right? And my integer array is going to be called numbers. Now typically what we want to do is when we make arrays, remember, is as a review again, we always make it a plural. So when I say, if I'm talking about number, if it's only one number, I would call the array or the variable number. But if I'm talking about more than one number, and it's an array of numbers, I might as well call it numbers because it's more descriptive. So we always add like a plural when we're talking about arrays. Okay, so int numbers is equal to new int, right? New int. Now usually I have to specify. There's two ways I can do this. I can specify the value, so I can say like, I don't know, 50 integers as an example, right? And end it off there. I could do that. I could do it like this too. I could say it's the square brackets, and then I could put in the initializer. So I can say things like 1, 5, 7, let's see, I'll do 1, 3, 5, 7, 9. All odd numbers, and 11, right? And then end this off with a semicolon. So this is an initializer which calculates how many of these I have. Calculates the number of array elements I need. That's one way of doing it. I could also use the shorthand, remember, for arrays, and I could take away all this stuff right here completely. So I can just go one of these, bam, right? So 1, 3, 5, 7, 9, 11. That's also acceptable syntax, right? If I do the array this way. Okay, so this is my array, 1, 3, 5, 7, 9, 11. And what I want to do is I want to create a private static method, right? That's here. So here's private static void. That's the method, and it's going to be basically, I want to take my numbers and show them, print them out, right? So I'm going to do one of these. So I'm just going to say, I'm going to call this calculate. If it's private, I'm going to put an underscore in there, right? And I'll say calculate and show. Calculate and show is going to take an integer array and it's going to be called the numbers. Now this is my local name for the integer array. I could still use the same name. It wouldn't be a conflict because it's a different scope. So calculate and show is going to take an array of numbers. So that means when I call calculate and show, right, I'm listening for an array, not a value of an integer. So if I call calculate and show just the way it's been written, I got to do one of these. If I say this it doesn't do anything because in this particular context it doesn't mean anything. But if I go underscore calculate and show, right, and I open it up, it gives me the code hinting. It says it's listening for an integer array called the numbers. So how could I do this? Well, I just have to put in the word numbers. That's good enough to send in. That'll send the value, the reference. It'll send this whole array in, this whole number array in by reference. So now if I want to show this array, I can do a for each statement. And in my for each loop, I'm going to say the item that I'm going to take in. So whatever the item is in my collection, I'm going to be declaring. So my item in the numbers is going to be number in, and here's my collection would be obviously the numbers, because that's what is local, right? This is my for each loop, and I want to say the number in, for each number in numbers, and it says type of object in the collection to iterate through, and then here it says type and identifier are both required in a for each statement, and here's the numbers, right? So number and numbers, and I want to do something. I want to say console write line, and I want to say I want to show the numbers. So and by the way, I have to declare what kind of variable number is. I got to say it's an integer, right? Because that's what it's an array of integers. That means this number is an integer for me to complete it. So I'm going to say number, and I'll use interpolation here like this, comma, like this, comma, and the number. So I can do that. I'm using a for each loop to swim through the array, right? And I'll call this my private methods. There we go, private methods. Right now there's only one. But if you notice here, I've got a for each loop, and it takes this method, calculate and show, takes one array, and I print out the numbers. If I run this thing just like the way it is, it's going to print out the numbers 1, 3, 5, 7, 9, 11, like this. Okay, cool. That's cool. But what if before I print them out, so here's number, I want to add something to each of these numbers. So I want to add a 1 to each of these numbers, right? So I'm not going to loop through this. The for each loop isn't the good thing to loop through, because my number is this value here is a constant. It can't change. I can see it. I can read. It's a read only, but I can't do anything to it. The only way I can do things to it is if I kind of go in here and I go I run a regular for loop, right? And the for loop, I'm going to call this index as an example, and it's going to be less than the length of the numbers dot length. Again, remember we talked about efficiency, loop efficiency. This isn't the most efficient loop, but it works. Let's just use this one for now. And I'm going to say, I'm going to kind of go in the numbers, and the square brackets, I'm going to say these numbers right now, the index, starting off the index, which is 0, right? And whatever that is, I'm going to increment the index by one number. So as I go through, I increment whatever's inside the value by 1. So now, originally it was 1, 3, 5, 7, 9, like up here in 11. It's going to be 2, 4, 6, 8, 10, 12. That's what it'll end up being when I print it out. Okay? Let's see that. So I'm going to just run that now. And when I do, I get my expected values, 2, 4, 6, 8, 10, 12. Right? That's cool. Well, when I come back here, if I was going to come back here and print it out again, right? So if I do the same loop, this one, take this whole loop, oh sorry, this one, this for each loop, take this for each loop, copy it, and move it up here, but just change, instead of it saying the numbers, it'll be number in numbers, right? Because this is the local name for the array. To prove that it's a reference type, right? To prove that it's a reference type, I'm going to also, by the way, I'm going to rename this thing because I want to make this, if I make this private as an example, if I make this private why does it give me this error if I make it private like this array? It says invalid expression term private inside main, because main inside here, I can't put an access modifier in here to make this private. If I move this array from here and I moved it out here into my program, so now it's part of my class program, right? But it's not in main, so I kind of moved it out here, and I did that. I can't leave it like this, right? Because now when I look at numbers, right, it's private. And do I have access to this thing? Well, no, unless I make this static. And if I do that even, it's not available. Take a look. Here's where it's numbers is available now. Numbers. And the reason why is because if I put the private or even public up here, until I put the static access modifier up there, right? It has to be, remember, it's a class, and all classes have to be created with an object. Now here, if I put it outside of main, it's available to both methods, to both the calculate and show method and the main method. I don't have to pass it into the calculate and show. Like for example, if I go down here and I see if I can access numbers, let's see if I can do that. So I'm just going to kind of say, with the name, just numbers. I have access to it. See, it actually comes up with code hinting, which means even though I made it up here, I put it up here, it's available to anything within my class scope, or anything within these lines. All this is available to. So if I do that as an example, and if I put it up here, it's available in there. Now I can change that, of course. If I change this private to public, not only is it available within my class, but it's now available outside of my class, to the outside world, to other places, other classes in the same namespace. Okay, so this is cool and all, but I don't really need to do this right now. So I'm going to take it off. We're going to get there, but I'm going to take this off and go back and put it here. And it doesn't have to be public static. It just has to be int, like this. Okay, cool. So I have something called numbers. I want to run this thing and see what I get. So I go, bam, 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. Why? Because both, when I go in 1, 3, 5, 7, 9. It goes into this thing, and then I do this I kind of do this addition, this iteration where I increment everything, right? And then I spit it out. But once I've incremented it here, it gets incremented out here because it's a reference type, not a value type. So I'm not sending in just the values. I'm sending in the cell locations too, right? And that's a dangerous thing about using arrays, passing a whole array into a method. Okay, so that's this piece. Let's go back. And it's going to mess up again. But that's okay, because you're going to see this thing look okay. All right, so here we go. So again, what I'm doing here is, this part is when we pass in command line arguments into my main, right? So if you notice, I have a string of arguments, right? Well, this arguments string comes from somewhere. It's main. Actually, our main program is waiting for some other argument to come in, right? This argument actually is right now is optional. I'm waiting for strings to come in, but if I don't receive anything, it's going to be okay. It's a string array, which is called args. This is a standard way we see our main. If I go back over here, you can see that main string args, right? But the only way this can come forward like this, right, as an example, is when we use the console itself. Like if I actually go to the console right here, and I swim to where my file is. So here I'm in the console, my command prompt, right? So I'm going to go, kind of go up one to another one, go to users, and from there I'm going to go to my name, and from there I'm going to go to Git Hub. Let's see if this is available to me. Let's do a PRR command. Yeah, I think I may have had it under, I think it's documents. So CD documents, right? And then here I have GitHub, right? And if I do another dir, I have all these projects. Now I'm going to go into our project right now. So CD COMP100. I think I called it lesson 10, part 1. Enter, and then do another dir. Here I'm into the lesson 10, part 1. I'm going to go into COMP100 again, and another dir, right? And now I'm going to go into my bin directory, and I'm going to go into my debug directory, and now I see my actual executable. This is the actual file that I made when I launched my code. So if I actually run this, this is actually a runnable file like you see any kind of executable. This is my application right here. And I got it encoded. If you notice this big long line, right? That's where I am. That's the actual location. It's in the debug directory, in the bin directory inside of my actual application. Okay, so if I run this thing, all I have to do is go like this, COMP100 lesson 10 part 1.exe. If I run this here and I press enter, it actually runs my application here in the console. Right? If I press star, it I do that again, it kind of clears everything because that's what I've asked it to do. So I can run it from here, from the console, as well as me running it through here, like by debugging. So if I do it from the console right in here, I can actually send an argument into main. Let me show you how to do that. So here's main. I'm just going to kind of swim back out. Here's main. It's listening for a string of arguments. Well, I can say if, right, and I listen for the string, if string 0, right, which means the first argument of the argument, sorry, if arg0, if arg0, right, I can loop through, if it's true, if that's true, if that's equal, if it's not equal to null, right, I can actually do that, arg0 is not equal to null, then what I want to do is I want to say console.writeLine, and I want to print out arg0, right? So I'm going to say you typed, and then string interpolation here, right? And then comma args0, right? So this is coming from inside like my main itself. It's actually, this is a signature for my main method, and I'm saying, hey, let's see how I can send something from the console outside of my program into my program, which is from here. So here I am in the console. This is my command prompt in Windows, right? I'm outside of the console, and I'm actually going to run my code again. I'm going to say this, but this time I'm going to put a space. I'm going to say, hello world, right, and press enter. Okay, and ooh, what happened? How come it didn't print it out? Why? Well, it sent something in here, but remember, I made these changes, and I didn't build my code. I didn't regenerate my executable file. So I go build. If I say build solution, right, now it becomes green. Now if I go back and do that again, so if I go exit, I kind of space up again, and I do the same thing like this after I built it. Let's take a look. So here I am, hello world, and press enter. It says you typed hello world. So I can actually send information into my code by doing that. And sometimes, when we make our custom code, a command line, a console application, we want to send some switches like -F, -C, -D, whatever, waiting for these extra commands. And what they do is they change the way we execute our code. We're listening for something, some kind of arguments from the user. Maybe they want certain things to be typed in. Like, for example, type in your name, and that could be something that I'm expecting in here. Like I'm expecting this lesson 10 part 1 to get my name, right? That's what the first argument is, right? Now here's something. If I'm listening for an argument, and if I go like this and just type in nothing, like this, right? Will it say? Will it do anything? Well, it says what? Look what it says. It says index was outside index was outside the boundary of the array, right? Because I'm listening for index 0, but there is no index 0 because my arguments are empty. What it's doing is it's assigning an argument if, only if, my arguments has a length. Can I go argument 0? So how do I rewrite this? Let's go back out and I'll show you. So here I'm in here, right? See, it's args. If I'm saying if arg 0, well, this is not really cool. What I should actually do is say something like this, right? I'm going to go like this. I'm going to say while, right? While, and what I'm going to say, maybe what I'll do instead of a while, I'll make it a for loop. For loop. For, okay, is, so for I is equal to, instead of I, we'll make this call, we'll call this index again. We'll say index. For index is equal to index as long as less than the args dot length, right? The length of the arguments, right? Then I want to do, right? I want to cut this and put it in here, kill these braces here, and it says console write line you typed 0, right? Well, it's not args 0 anymore. It's args index if there's 1. That's what's going to happen in there. And you know what I'm going to say? For the argument, and I'll say this, for argument, we'll do one of these. I'll reformat this thing. Hold on. Wait while I reformat this thing for you so you see what I'm doing. So for argument blah blah, comma, right? And in my first argument is going to be index, right, plus 1, index plus 1, you typed args index. So the reason I'm saying index plus 1 is because for argument 1, first one, right, then you typed that. For argument 2, which is the second argument, you typed this. I can put more than one argument. Let's try this out, if this works. First, I'll build this thing. I'm not going to run it. I'm just going to build it, right? So I can try the command line down here. Okay, let's try it again. So I'm going to go up 1, and and this time I'm not going to enter anything in here. So there's not going to be any argument. Let's see if it errors out now. No, it doesn't do it. It doesn't show it, right? But if I put an argument in like this, you are scary, right? And press enter, it's going to say for argument 1 you type U, for argument 2 you type R, for argument 3 you type scary. If I only did it in one line, same way, but instead of this, I just did it all in one. You are scary. That's only one line. It's my first argument because I've enclosed it in quotation marks. If I do one of these and try again, and usually you see more of these kind of things, I'll have different arguments, minus F, minus G, minus R, minus U, minus X. And that might mean something to my program. If I type it in, then I'm going to see these arguments come through. Minus F, minus G, minus R, minus U, minus X in order. So now the array is actually 5 arguments long, and I can check to see how long these are, and I can check to see if I have an F in my array, then it means that I have to turn this piece of functionality on or off in my program. Okay, that's what this thing does, and it's all done by command line. So this is a true command line application now because I'm actually running it from command line. Okay, and I'm not starting it here. All I've done is build it. I don't have to start this. This is my debugger. Here, when I do a build, I actually build my solution out, right? And when I debug, if I go debug, right, I can start debugging, right? I can also start without debugging. Start without any debugging. That's another option. I could do that too, right? Usually when we press run, right, so if I just click this button here, I'm starting my program. But here I've done it so I can just start it from command line, like the actual command line itself. Let me just update that on GitHub. Excuse me. I'm going to Team Explorer. I'm going to go to Home. I'm going to go to Changes, and I'm going to say demonstrated command line arguments passed into main. Right? And press Home and unsync commits and sync. Okay, cool. So I've done that, and now let's go back out to this thing. So that's what. So really, my main method is a method. It's just we don't use it. Oftentimes, we don't listen for an argument that comes into the main. We just ignore it, and we see it all the time. It's in front of our face, but we're like, meh. Right, we don't do anything with it. And that's what we've done. We've actually run a for loop, right, that runs through each of the arguments, just like I did. Okay. Some people, it says, want to write a main with a return type of integer instead of void, right? Well, this is interesting because what it's going to do is you can return, now the last statement in my main has to be a return code, right? So usually what I can do is I can say if it's a return code of 0, that means we got good execution. If it's anything else, it'll be interpreted as an error code that I can output. So I can create my own error codes that my project outputs from my return. So instead of returning void, I can return an error code. Like error code, I can make my own. Error code 100 might mean something like, you forgot to enter this thing, or this file is missing. I can create my own error codes for my program, custom error codes. Sometimes it says here you want to prefer to write main with public access. And again, the default is private. And a public main can be called by some other class. Right now, we don't need to do that. Okay, and I'm not going to talk about GUI because we're not talking about GUI, right? And really, in a nutshell, we've kind of hit all we have to hit with methods. Now we've gone through all the methods. So any questions around that? Because at the end of the day, what we want to try and do is, this is our last module, lesson 7. Lesson 7 is up, right? It's on thing. This is our last module in the lesson, and what we want to try and do here is now we're going to have a series of assignments. Like for example, we're going to give, obviously the test was supposed to be today. I'm going to move that out. But what we want to try and do is practice methods as much as possible. So let's take a bit of a break. It's 7:30 now. We've gone for almost an hour. And then we'll go in to do some more practicing with methods. And what I want to do is we're going to create an assignment base that I'm going to make for you tonight. I'm going to give it to you so you can complete it by next week. Right? So let's just do that. So I'm going to go